Hi, I'm Bob Aiken. I've been a hardware retailer most of my life, and for the past 26 years, I've been training people who work in hardware stores, home centers, and lumber yards on ways to sell more electrical supplies. The folks who bring you the Do It Best training break have asked me to dedicate this segment to helping you better understand how a household electrical system works. Let's start with the main component of your entire household system, the electrical panel, also known as the main. We've removed the cover from this panel so we can show you what's going on underneath. If you add another panel off of the main, that panel is called a subpanel. You would add a subpanel if you needed more space for individual circuits in your house. For example, if you had wanted to add another receptacle circuit, but your main panel was completely full. A subpanel is like a main without the main breaker, and it usually mounts next to the main. You don't gain more available power by adding a subpanel, but you do gain more space for circuits. The main panel receives electrical pressure, also known as voltage, from the electric company's transformer. The transformer is either hanging on a pole on the street or else it's located on the ground near the house. On the ground, the transformer is usually in the form of a big green box. The transformer supplies the voltage on two separate lines entering the house. These lines are known as a service entrance. Each line feeds one bar on each side of the main, so either one or both bars can be used to supply power. There's also a third wire that comes from the transformer to the panel. That wire is called the neutral wire. We'll talk more about the neutral wire in a few minutes. When you tap off of one bar, or to put it another way, when you use only one bar to supply power, it's called 120 volts. When you tap off of both bars at the same time to run a single device, it's called 240 volts. You may have heard people refer to 110 volts and 220 volts, but if you used a meter to measure the actual pressure, you would find that it's closer to 120 volts and 240 volts. For this reason, 120 and 240 are the best numbers to use when you're talking about household voltage. When you turn on the main breaker in your panel, it allows the voltage pressure to push electrons through the wires in the electrical cables that make up your circuits. A circuit is a combination of wires, such as the wires found in electrical cords or cables, that allow electrons to flow to and from an electrical device that will use the power. The movement of those electrons through the wires is called amperage, and it's what causes your various electrical items to operate. Fuses or circuit breakers in the panel box protect the circuits to prevent too much amperage from flowing on the wires. The amperage of the breaker or fuse should always match the amperage rating of the cable. Some electrical appliances such as clothes dryers, electric ranges, and water heaters require more amperage than others. These appliances are known as 240 volt devices because they need two lines of pressure to operate. When you need to connect to your panel to get 120 volts, you use a single pole breaker. When you need 240 volts, you use a double pole breaker, which will automatically connect to both bars in the panel box. I think it's easier to understand how electrical pressure works if you think of it like water in your plumbing system. The pressure needed to move the water through your pipes to your various fixtures is supplied from a pump somewhere, either at the city water department or from a pump in the well. An electrical breaker is a lot like a water valve. When you turn the valve on, the pressure pushes the water through the pipe. When you turn a breaker on, the electrical pressure pushes the electrons through the wire. Another similarity between water and electricity is that once the water reaches a fixture, let's say a faucet, and gets used, it then flows down the drain pipe and into the ground. Keep in mind that the drain pipe is often white. With electricity, the electrons flow to a device that will use their energy, like a light bulb, and then they flow to ground on a white wire, called the neutral wire. So you see, the white neutral wire in an electrical system acts like the white drain pipe in a plumbing system. There's one big difference between water and electricity in terms of how they flow. Water flows in only one direction, but our electricity in our household systems is referred to as AC, or alternating current, because it flows back and forth on the wires. The direction of flow changes 60 times every second. I won't confuse you with a detailed explanation of how and why that happens, but for our purposes, just know that this change of direction is referred to as cycles or hertz. In a 120 volt circuit, the white neutral wire has to be connected to ground, or that movement or cycling effect won't work. With a 240 volt circuit, it's a bit more complicated. Remember that 240 volts is just two separate lines of voltage pressure being used on one appliance to give it more power. The difference between 120 volt and 240 volt circuits is that with 240 volts, you do not need a white neutral wire. That's because the two hot wires push the electrons back and forth 60 times per second between each other, so the electrons don't have to go to ground. Remember, it's the movement of the electrons back and forth and not the need to go to ground that makes an electrical device work. Now, you may have noticed that to make a clothes dryer or electric range work, you need 3 conductors plus ground. If so, you're probably wondering why that is. The answer is pretty simple. You need 2 conductors to run a device on 120 volts. One is black, which is called hot because it's the one that's powered by the panel. The other is white, and it's the neutral one that returns to ground. It also takes 2 conductors to run something on 240 volts, but both these conductors are hot. One is black and the other is red. Ranges and dryers use both 120 volts and 240 volts. When you operate such a device, you need 3 conductors because you need 2 hot wires to run the 240 volt device, and you need the white neutral wire to run the 120 volt device. Let's consider a clothes dryer as an example. The 2 hot wires, red and black, supply power to the 240 volt heating element. The white neutral, along with one of the hot wires, operates the 120 volt timer and any other 120 volt devices on the dryer. It doesn't matter which of the 2 hot wires you pick to run 120 volts to a device, since they both contain the same voltage pressure. Try to remember it this way. You need 2 conductors to run 120 volt devices, and you need 2 conductors to run 240 volt devices. But it takes 3 conductors to operate any appliance that has 2 different voltage pressures in it. Newer range and dryer cables also have a 4th wire that's green. This is a grounding wire, which we'll talk about in a minute. After your circuits leave the main panel, they run through your house and provide power to receptacles, lights, appliances, and so on. Each cable that is used to connect to these devices is sized according to your local codes. These codes are based on the National Electric Code guidelines. The National Electric Code is also known as the NEC, and it's not law unless your state, city, or town adopts it. For this reason, you should always tell your customers to check with a local code inspector or licensed electrician for the latest code information. Here are some cable recommendations for specific circuits. The smallest size cable your store sells is called 14-2WG type NMB. This cable is white and it's rated to handle 15 amps of current. The first number, 14, refers to the gauge or thickness of the wire. One odd thing about electrical wire is that the smaller the gauge number, the larger the diameter of the wire. The second number, the 2, represents the number of insulated conductors in the cable. The WG stands for with ground, which means that the cable has a bare wire in it that connects to a metal piece on any electrical component that could accidentally contact electricity, such as a metal box or a metal strap on a switch or receptacle. This helps protect you from electrocution if current accidentally leaks to the metal surface. Although grounding wires are designed to protect you against electrical shock, they do not guarantee that you won't get electrocuted. Electricity always takes the easiest path to ground. If you were standing in water and touched electricity, the current would flow through you rather than through a grounding wire because you would be the easiest path to ground. You don't need to attach a grounding wire to anything plastic because plastic is non-conductive. The letters NM stand for non-metallic, meaning that the cable sheathing is made of plastic. The last letter, the B, indicates that this is a newer type of cable with a better sheathing that will operate in a higher temperature environment than the older NM cable. All NM cables today are rated with a B, so you don't have to be concerned about that rating. Cables that are 14.2 with ground type NMB are suitable for lighting circuits, some receptacle circuits, and other low amperage items. But I highly recommend using the next larger common cable size, 12.2 with ground type NMB, for all regular household receptacles. A 12.2 WG type NMB cable is yellow, which makes it easy to identify. It's rated for 20 amps of current and is well suited for receptacle circuits. This cable is specifically required as a minimum size for all bathroom circuits today, including the light fixture circuit. Other uses for this cable would be for small kitchen appliance circuits, refrigerators, built-in microwaves, and washing machines, just to name a few. The next larger cable is 10-gauge wire, sold as 10.2 with ground and 10.3 with ground. Both of these are orange. The 10.2 cable is used for electric water heaters, while 10.3 cable is most commonly used for electric dryers and cooktops. Be careful about what you suggest for a cooktop, because manufacturers have recently begun making a type of cooktop that has 5 burners instead of 4. It looks like 4 burners, but one is a dual burner, counting as 2. That type of cooktop takes 8.3 with ground cable, not 10.3. Cable rated as 8.3 with ground is often sold for regular electric ranges, but I don't recommend it. When you help a customer select a cable, it's important to help them think about what they may do at some time down the road. Lots of people will upgrade their appliances over the years. A customer who currently has a regular electric range might someday purchase a range that has a self-cleaning feature. The problem is 8.3 cable won't be sufficient for the new range. To safely supply power to the new range, they'll need a bigger 6.3 cable. It's best to suggest the largest cable the customer might need in the future, because when the time comes that they need a larger cable, they probably won't change it, and that could lead to a fire. As you can see, it's not always easy to remember what cable does what job, so it's a good idea to keep reference charts for cable usage on hand. You can readily obtain these charts from the cable manufacturers that supply Do It Best Corp. The charts make it easy to find the proper information for your customers. It's important to remember that giving out incorrect information to a customer is the worst thing you can do. When it comes to electrical work, using the wrong item for the project can result in a fire, serious injury, or even death. The best thing you can do to help your customers is to give them the correct information by either looking it up or asking someone who knows. And of course, when a customer isn't sure how to correctly complete any electrical project, recommend that they contact a qualified electrician for help. In all cases, do whatever you need to do to ensure that your customers get the right information. Your customers will greatly appreciate your efforts, and that will keep them coming back.